Hello, this is Mike speaking on behalf of Team DomDom for the Impact Test Lab number 4, in which we used an impact tester to test the impact strength of two specimens, a low-carbon steel specimen and a aluminum specimen. In addition, we used two GoPro cameras to record the video footage, and we used this video footage to capture the velocity, or should I say calculated the velocity from those videos. Moving on to the discussion and results section of the experiment, the attempt at comparing the impact testing standards and strength values to the experimental results remains unknown after researching the standards and strength values on the internet. All of the files had to be paid for in order to ascertain that information. One can conclude, however, that the data presented on the page is plus or minus 10% of the impact testing standards and strength values. If the experiment went well, however, there is no way to confirm that with only one trial for each specimen in order to deduce that theory. One way to fix that problem would be to include at least 3 trials for each specimen with the impact tester if the lab were to be repeated. The impact strength for the aluminum was 27 joules and the low carbon steel had a value of 8 joules. The aluminum specimen was bent down the center when compared to the steel specimen that had a mostly clean cut down the center. This leads to the conclusion that the aluminum specimen was ductile and the steel specimen was brittle. It is safe to assume that the higher the impact strength is, the more ductile the material will be because it will have absorbed more of the energy from the pendulum swinging down and striking the specimen. As for the velocity, the aluminum specimen traveled at 115 inches per second after being struck by the pendulum compared to the steel specimen traveling at 50 inches per second. The only reason for this may have been because the steel specimen has a higher density than the aluminum specimen. In addition, since the velocity of only one side of the specimen was recorded, there is considerable error in the velocity because there was only one trial and one side of that specimen is not enough to conclude an accurate velocity for all specimens of that material. The reason for only recording one side of the specimen was the simple reason that the video did not provide any information on the other side of both of the specimens. After researching various impact test experiments, it would be interesting in future experiments to test a specimen at differing temperatures and compare ductility of that material at those differing temperatures.